Hi everyone, my name is Zinal and I'm here to present our project on skincare product review analysis. I'm joined with my team members, Tianzi, Likhita and Parya. So let's talk about skincare industry is rapidly growing, valued at over $140 billion and projected to reach $190 billion by 2027. 93% of the consumers rely on online reviews for purchasing decisions, but manually analyzing them is overwhelming. Traditions tools only focus on star ratings, missing deeper insight. Contradictory reviews and information overload often leave consumers confused. That's where natural language processing comes in picture, automating sentiment analysis, summarizing key insight, and providing both consumers and brand with accurate, scalable, and meaningful data-driven solution. Next slide, please. So, our goal is to develop fine tuned models that can be applied to future beauty applications. This model will analyze consumer reviews to extract key insights, helping consumers make better purchasing decisions based on the experiences of previous buyers. Next will be explained by Tianzi.
For this project, we want to capture the sentiment signals on the review text. First, we need to do the data pre-processing and add sentiment labels like positive, neutral, or negative by the ratings that user gives to the product. And then we are going to do the feature extraction, which means transform raw text into the numerical representations that the classifiers can understand and work on. We will use BART and LSTM to get the contextual word embeddings, and the output will be fed to the classifiers. For the classifiers, we have several options. First is to use logistic regression or as SVM, and second is to fine-tune the BART and LSTM model we use for the previous step, or we can train a dense layer as a classification layer and put it behind the pre-trained model. After that, we will do the performance evaluation and optimize our model. For the data set, we're planning to use Amazon Beauty Reviews. It's collected in 2023 and it has not only the user reviews, but also the product metadata containing the descriptions, price, and type of the product, which means that we can not only analyze the review, but also we can group them into types and analyze by brand and gives us richer information.
So if possible, we want to analyze specific parts of a review rather than just the overall sentiment. For example, if someone reviews a foundation and say the color is perfect but the texture is too dry, we need to recognize that the color gets positive feedback while the texture gets negative feedback. So to do this, we first identify key aspects in each review using a technique called topic modeling like LDA. Then we use a model to predict the sentiment for each aspect separately. However, these aspects don't come with ready-made labels, so we can use a pre-trained AI model like BERT to understand the context. And if we want to improve accuracy, we need to manually label some data for training and evaluation. So now let's go over the key algorithm we might use for our sentiment analysis, like supervised learning, where we train our model using labeled data so it learns from known examples and predicts sentiments in new data. Naive Bayes, which is a simple, fast, and effective model based on probability. It assumes words appear independently, making it great for text classification. And SVM, which is a powerful model that finds the best boundary between positive and negative sentiments. It works well with text data and high dimension features. And we also can use random forest, BERT plus LSTM. And using a mix of these algorithms, we can make sentiment analysis more precise and insightful.
We have found a couple of projects where a similar approach is used to perform sentiment analysis on different datasets. In this first project, the dataset being used contains movie reviews from websites like IMDb. The author is using fine-trained BERT and LSTM models to perform sentiment analysis and classify the reviews into categories like positive, negative, mixed, or very negative. BERT understands the context of each word by looking at the words surrounding it and develops contextually rich word embeddings. These embeddings are then fed into the LSTM layer. It processes the sequence of words in the entire review and captures how different parts of the review are connected. This will help to understand the overall sentiment of the review. In the next slide, please. In the next project, the dataset contains reviews from Amazon on a broad category of products, not just limited to cosmetics. These reviews are categorized as positive or negative using BERT and LSTM. In the last one, the author is performing sentiment analysis on the dataset containing reviews on cosmetic products. These reviews are obtained from Twitter. Instead of BERT or LSTM, the author is using supervised learning algorithm (SVM) to perform analysis and classify the reviews as positive or negative. Zinal is going to explain challenges.
Yeah, as we move forward with the skincare review analysis, there are several future challenges that we might face. First is domain-specific language like pore-friendly or acne-safe can be tricky for models to understand. Second is contextual sentiment is important. Words like oily can have different meanings depending on the context. Like third is one we must have to tackle the data quality issues such as fake reviews or sponsored content which can distort result. And we need to focus on ingredient specific analysis, understanding consumer sentiment towards individual ingredients. And lastly, we have to analysis based on skin type variability. Complicates analysis as the same product may not work well for dry skin but poorly for oily skin. So these challenges are why we need to tools like BERT to properly understand skincare reviews. Thank you.